Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of DevSecOps Zero to Hero series, and in this episode, we will focus on DevSecOps for Git. Just a backstory. In the first episode, we focused on Introduction to DevSecOps, where we learned what is it, why is it used, and most importantly, what is the scope of DevSecOps. And while learning the scope, we learned that DevSecOps is not only for CI/CD, but it is for every single activity that DevOps engineer performs. Now, one of the most common activities is Git. That's why in today's lecture, we will focus on securing Git. Now, you might think, but Git is just a utility. Git is just to store source code. So, what's in DevSecOps for Git? Let me tell you, this is very, very important, and there is a lot to do when it comes to securing Git. In today's video, we will focus on 10 most common ways in which enterprises secure Git, or the best DevSecOps engineers secure their Git repos. We will start with .gitignore, one of the most easiest ways and the first things that you can do. Then we will learn about pre-commit hooks. An interesting thing, but something that you should also implement in your organization. We will first learn pre-commit hooks using a custom script. Then we will go a step ahead and we will learn how to implement pre-commit hooks using a common utility. Then we will focus on repository scanning. So a lot of times existing repos in your organization, they might also have secrets or sensitive information. We will perform scanning on the repositories using Git leaks. Not only the latest commit, but also the commits that are made maybe 3 months, even 6 months before. Then we will learn how to integrate Git leaks into GitHub Actions, Git leaks into CI/CD, so that even through pull requests, accidentally as well, users cannot commit secrets to the repo. After all this, we will switch the gears and we will move towards RBAC. We will learn branch protection rules, how you can secure your main branch and other important branches in the repo. Of course, we will talk about RBAC itself, how you can grant different roles in the Git repository. Easy one. Then we will learn about mandatory reviews, something that not a lot of people talk about, but in many companies, you want certain engineers or certain AI agents to review every single PR on the Git repo. How do you achieve that? You can achieve that using mandatory reviews. We'll also talk about. Then we will learn about code owners file, something that is becoming a standard these days, followed by open source repositories from a long, long time. And these days, enterprises also started adopting it. Finally, we will learn about Dependabot. So Dependabot is again a popular thing which can auto fix the security issues on the repo. So these are 10 things that we are going to learn in this lecture. Now you don't have to be overwhelmed because we will go topic by topic, and for most of the topics here, we will also perform the demos. After watching the video, just spend 15 more minutes and go through the README file that I created. I created this README file with every step that I'm going to execute and every script that I'm going to use, so that you not only watch the video, but also get the practical hands-on experience. It's a free README file. It's in the same repository in the Day-2 folder. Perfect. Now that the context is clear, let's start with .gitignore. As I told you, a very, very simple security thing that you can implement for your repos. Let's understand this with an example. Imagine there is an organization and this organization has a microservice. And this service is within their Git repository. So obviously, the source code of the service is within the repo. Now developers working on this repo, they clone the source code and they work on the local changes. Let's say one of the developer is working on this repo and this developer is basically working on database changes. So developer made some changes to the Python scripts that updates the database, and developer created a .env file or updated a existing .env file on the developer's local machine with DB password. So developer made the changes, developer tested the changes, everything is fine. Now what this developer did accidentally, along with the Python script, along with the DB changes, also committed the .env file. Now this becomes P0 issue for your organization, the most critical issue for your org, because a secret, especially the database password, is committed to the Git repo. Why is it critical issue? Because Git never forgets things. Git is a version control system. Even if you revert the commit, you can perform Git revert. By the time you perform Git revert, you never know. A lot of other people must have cloned the repo. If it's an open source repository, some people must have even forked the repository. So they must have created a private or public copy of the repo. You don't know. So you can perform revert. You can use some uh, repo cleaners. You can use some external scripts. Even you can get in touch with GitHub support. You cannot do anything because the password is already shared with others. Only thing that you can do is change the database password. You never know what are the implications of it. So what I'm trying to say here, instead of all this, you should avoid the situation. Instead of talking to the GitHub support, reverting the commits, failing to do it, checking who cloned it, why not prevent something of this sort? So the first step to do it, or the easiest thing to do it, is to use the gitignore file. I should say .gitignore file. Now what does this thing do? Very simple. .gitignore file tells Git, hey Git, I will provide you with list of files that you should not track. The default behavior of Git is to track the files, right? What does Git do? It will track every single file in your repo or on your local machine. But this is a special file which tells Git, hey, don't track the files that I have with me. So the DevSecOps engineer will create a .gitignore file, and within the .gitignore file, DevSecOps engineer will make entries of the files that should not be tracked by Git. For example, .env, PEM file, or if working on Terraform, TF state file, maybe IDRSA file. This way, a good DevSecOps engineer will list down even 100 common files that should not be committed to Git. I'm not joking. To make it clear to you, if you look at our DevSecOps Zero to Hero repo, I have a real-time .gitignore file that enterprises use. Look at the .gitignore, you will find a lot of entries. Now, of course, I exaggerated this file. I added things that not a lot of organizations would have. For example, I added Python related files and NPM related files as well. Maybe organizations would only have Python or NPM. But what I'm trying to tell you here, a good DevSecOps engineer should dish down every single possibility. So in this file, I added .env as well. Now, if someone is working on this repo, imagine this is the actual repo where developer is working on. Even if developer tries to commit .env file intentionally, Git would not do it. Let's see that. We will see this practically. So what I'll do, I'll first clone this repo, git clone followed by the repository URL. Here we go. I'll switch the directory DevSecOps 0 to hero. Nice. And here, intentionally, I will create a .env file, and within this, I will store a db password. db password is equals to Veeramalla. Okay. Now I will add git to track it. Let's see. Git add .env. Okay. What does it say? The following paths are ignored by one of your .gitignore file. So Git is saying, hey, I cannot do this because there is a .gitignore file here, the one I'm talking about, and this .ignore file told me that I should be ignoring .env. But Abhishek, what happens if I try to commit it or ask Git to track it with other files? For example, I will create a testing.py, and here, let's say I will add a simple thing that print, my bad, print hello. Okay, can we fool Git by pushing both these files together? So what if I do git add -- all? Will Git be fooled? Let's see. If you do this, now what Git does, it did not throw you this error, the error that you were seeing earlier, but if you do git status, Git is only tracking testing.py. It did not throw the error, but it did not get fooled as well. It said, I will still stick to the .gitignore file. So this way, DevSecOps instance can take the first step in the organization. Introduce .gitignore. Now introducing is very simple. You can take inspiration from this file, or you can talk to your developers, you can talk to your QA team, list down all the files that you want to avoid, create .gitignore, the same file, the name has to be same. Create this file. Now you might have only 5 entries in it. Save the file and do git add .gitignore, and most importantly, you have to push this file to the repo. Why? So that next time other developers clone this repo, they will also have .gitignore on their local machine. So you don't have to go to every single developer and tell them, hey, please take this file and keep it in the, or have it in the same folder of your Git repo. You don't have to tell everyone, just commit that file to the repo. It's a best practice that you can do. So this is about our first section, that is .gitignore. Now let's move to the next one, pre-commit hook. The reason for learning this concept is simple. Now .gitignore, although it is a good concept, if you observe carefully, here you are responsible for providing the list of files. Okay. So in the .gitignore, you provided that, okay, don't track .env, don't track pem file, don't track xyz file. But what if secret is in the Python file itself? You never know. There can be a junior developer who is working on a .py file. This time the developer did not create .env, but because a junior developer hard coded the password within the Python file itself. Now added something called secret, and that secret is still in the Python file. It's added, it's committed. Or there is a junior DevOps engineer working on Terraform related files, that is the .tf files, and in the .tf files, the junior DevOps engineer hard-coded AWS secret and forgot to revoke it. Tested, forgot to revoke it. Now, in this case, .gitignore can't help you, because in the .gitignore, you cannot say .py, star.py. Okay, ignore every Python file. You cannot say it, or you cannot say star.tf, ignore every Terraform file, because that's not possible. These are the files that should be in your Git repo. What will you do in this case? In this case, as a DevSecOps engineer, you have to introduce pre-commit hooks. So .gitignore is for known files. Pre-commit hook is for patterns. Okay, here you will rely on the pattern, not on the files. So within the patterns, you will write a custom script, maybe a shell script, and you will say look for secret in all the files that developer is committing. Look for tokens in all the files that developer is committing. Look for password in all the files that developer is committing. Even if developer has 100 files, this script will look for the patterns in 100 files, and if the pattern is matching, the script, the pre-commit hook will block the commit. I'll show you in practice, right? It's very easy to understand if we demo this. So this time, what we will do is we will add a pre-commit hook to the .git. Where will be pre-commit hook added? It will be added to the .git. So if you go to cd.git, here you will find a folder called hooks, and in the hooks folder, you have to create something like pre-commit. So you can call it pre-commit.sh. Even if you don't call pre-commit.sh, Git understands by default it's a shell script. So what you do here, you write a shell script, something like this. Again, don't worry, the script is in our GitHub repo. I'll walk you through the script. Okay, shebang /bin/bash, the starting point of the shell script. Echo, running a native pre-commit hook. This is something that I added. And here, I am looking into the git diff. So every time developer runs git commit, git diff is performed, and on the git diff, I am looking for the secret keyword. If there is a secret keyword, instantly I am saying secret detected, block the commit. If there is no secret, okay, go ahead and pass it. I don't have any problem. That's what pre-commit hook says. Now I'll show you this in action. First of all, I'll save this. chmod +x pre-commit. You have to do it because it's a shell script. Go back. Perfect. Now I'm on the root of the repository. Now I'll do one simple thing. I will create a text file. Okay. So this is a text file I'm creating. And this text file has something called secret. Just like a Python file, I created a text file and it has cat test.txt. Okay. So you can see it has a keyword called secret. Now I'll do git add test.txt. Let's say developer did it and developer tried to commit it. Git commit -am test commit. Okay. Now if what we learned is right, this commit should be blocked. Enter. There you go. Secret detected, commit is blocked. Now what does a developer do? Very simple. Okay, developer understood. Oh, I did a blunder. Let me just fix it. So developer goes to test.txt. Okay, developer removes this line. Developer will have other lines of the file. And now if developer tries to commit test.txt followed by git commit command, this will go through. This is the purpose of pre-commit hooks. Once again, very simple difference. .gitignore that we learned is working on the files that will avoid committing of secure files to the Git repository, files that are sensitive like .env or Terraform files. Whereas pre-commit hook, as the name suggests, it's a hook that you are writing. It's a script that you are writing that will see for a particular pattern. In our case, I looked for the secret pattern. Now you might say, but Abhishek, what if, instead of a single thing, right? Here you are looking for a secret pattern. What if developer commits token? Or what if developer commits DB password? What if developer commits something like, let's say, API keys or Terraform related AWS credentials? How do you prevent that? You know, I'm good at writing shell script, but I cannot handle so many conditions in the shell script. Going back, so in the .get, in the hooks, in the pre-commit hyphen, okay, here I just handled one condition that is secret, grep hyphen I. What if I have to look for token as well? Then you have to write another if condition. What if you have to look for DB password? You have to write another if condition, or you have to enhance this. This way, you don't know what are the common patterns. Or maybe you are not good at writing the shell script itself. You are a DevOps engineer, but you don't know how to write good scripts. Don't worry, even in this case, there is something which is pre-commit framework. So if you go to the pre-commit website, so this is a framework. What this framework does, it uses something called Git leaks, right? Git leaks, and using Git leaks, it will help you. You don't have to write the script. Now I'll show you that. Okay, same thing what we learned, but this time without writing a script. So first of all, I will delete the script that I wrote, rm-r dot get followed by hooks followed by pre-commit. Okay, I deleted the shell script that I wrote. Now, the first thing that you have to do is to install the pre-commit framework. If you are on a Linux machine, just run pip install pre-commit. If you are on Windows, you can go ahead and try it, but most likely it is recommended to use a Linux environment. Go for something like WSL, because a lot of times these framework won't work on your Windows machine. Anyways, you can give it a try, but in your organization, you will work on a Linux environment, so you don't have to worry. Okay, so pip install pre-commit. I am on my Mac. I will run brew install pre-commit. Okay, so the framework is installed. I have the framework ready. Now, all that I have to do is I have to just add. It's in our Git repository. Go to the README file. So you have to add a pre-commit YAML file. So just add this pre-commit YAML file. Create this vim dot pre-commit config.yaml, and within this add these 4 lines. As I told you, this is using Git leaks internally. What is Git leaks? Git leaks is a open source project, so it's a free project that anyone can use. Pre-commit is calling this Git leaks, and Git leaks is doing the job for you. This is basically handling the script that you wrote in the previous case, but in a much better way. And one more advantage of Git leaks is that it can work on all the repositories that you have. You don't have to go to every single .git. You can just use the pre-commit framework and use this configuration file for all the repositories that you have. Just to pre-commit install. Okay, I will run pre-commit install, and it says, okay, I created .get hooks pre-commit file for you. What we did in the previous case, we wrote this. Now what pre-commit hook did? It wrote this script for us, or the pre-commit framework wrote this script for us. Now let's verify. I will create a secrets.env file. Okay, where in the secrets.env, I am adding AWS secret access key. I will add this git add secrets.env, and I will try to commit this. Git commit adding some secrets. Let's see what happens now. Initializing the environment, you can see it. It called the git leaks. It is verifying. This will do on every commit. Sometimes it might take time. You have to be patient. But for security, I think you can do it. There you go. So it says, hey, I'm blocking your commit because you added AWS secret access key. And this secret access key is added to the secrets.env file. So it is saying what is the secret, and it is also saying the file in which you added the secret. Again, what a good developer would do? Oh, I accidentally committed the AWS access key to the secrets.env. Let me go ahead and delete it. So both the Git leaks and your custom script is doing the same thing. But in this case, you are writing the script, whereas with pre-commit framework, you are not writing the script. And it can handle the things in much better way. It provides you the information, it provides you the name of the file, and it can also identify not only regular patterns, but different patterns that are vulnerable. So we learned about .gitignore, we learned about pre-commit script, and we learned about pre-commit framework. Now let's see how to scan repositories. Now we are slightly switching the gear. What if you joined as a DevSecOps engineer and you want to see, Abhishek, I have this repository from 3 years. I want to see 2 years ago if anyone committed a secret to this. Because right now, if I look at these files, all these files are okay. There is no sensitive information in it. But what if I go to the commits? I go to commit that is 1 year ago. And in this commit, developer made a secret or committed a secret. Now, because this is Git, Git never forgets things. A hacker can look at all your commits. A hacker can look at all the files in the repo, history along with the latest. And if the hacker finds the secret, then that's it. Some developer might accidentally committed a secret. Developer realized it. Just to be safe, developer immediately reverted it, and developer thought it's all fine. Hey, I did a mistake and I covered the mistake. But no, Git does not allow you to do that. As a DevSecOps engineer, it is a good thing to scan the repos. Once in a while, perform the scanning. How will you do it? What you can do is you can use the same Git leaks. Git leaks detect -v, or you can just run git leaks detect. That's it. One single command. And you can see it scanned all the 11 commits and it says one leak found. Now this is because we have added the secrets.env and that is actually detecting from there. But anyways, what git leaks detect does, it scans all the 11 commits and it gets the information to see if in any of these previous 11 commits, if a developer committed a secret. So this is what you need to do as a DevSecOps engineer. Plan it as, once in 2 months activity or once in 3 months activity. You can also run it as a cron job. Just clone all the repositories. If you have 10 repositories, clone all the 10 repositories and run git leaks detect. Perfect. Now, okay, Abhishek, this is all on the local. Okay. Now, a developer might follow the instructions. Some developers might not follow. Even if I share .gitignore file, okay, some developer might not add it. A developer is new, they might ignore. Or I will share the pre-commit framework, but developer might not install the framework. What can I do? I still want to secure my repository. Now, the only possibility that you have is to create a CI/CD and make sure every time CI/CD runs on the repo. So I'll do that now. Basically, on this repo, let's create a new file, that is the CI/CD file. How to do that? Add a new file, dot .github. Now this is in your control as DevSecOps engineer. Workflows, and here add a workflow, something like this. Okay, there you go. So the name of the workflow is git leaks. It runs on every pull request. It runs on the push request, even on the workflow dispatch. And this is the job. Now don't think I'm writing this. This is copied from the git leaks documentation itself. I haven't written even a single line of code here. I just copied it from official git leaks documentation. And anyone would do the same because I don't know this action. I have to get this action from git leaks documentation. I just copied the entire thing. And when you do secrets.github token, you don't have to provide the token. By default, GitHub Actions, it has the default token. It will use the default token. Now let's see how this works. Okay, I will commit this change. Now, imagine your developers did not add anything and they try to push a password to the main, or they try to push the same AWS secret file. Whatever we used, they try to push the same thing to the repository secrets.env. Let's see what happens. I will create a branch. Okay, so let's do that. Create a new branch. Let's call this as test branch. From the main branch, I'm creating the test branch, and in the test branch, I am adding this file. I'll call this as secrets.env. Okay, and in the secrets.env, I am adding the same sensitive information. Echo or AWS secret access key. Perfect. Now I will commit this file. This should go. I'm committing this to the test branch. Ideally, I should not do it, but just to show you, I'm implementing this. Now, from the test branch, I will create a pull request to the main branch. Let's see what happens. Okay, we will create. Now on this pull request, what will run? The GitHub actions. The GitHub actions for the Git leaks workflow. Okay, we will create the pull request. Instantly, the Git leaks workflow should run. Okay, my bad. I did a very simple mistake. So here I directly added a workflow file. What I should be doing, I should create a folder, right? The folder name should be workflows. My bad. So workflows, and within this, let's add something like gitleaks.yaml. Okay. So I missed that. Anyways, commit. Perfect. Okay. Now let's see. We'll go back to our pull request. This is our pull request. Okay. So because the pull request is already open, what we will do, we will simply close the PR and create a new one. Okay. Close the pull request. And this time, go back, new pull request from test to main, ability to merge. Okay. Create pull request. Okay, now the git leaks pull request check is working. And you can see here, the check clearly failed. Let's see the reason why. Run git leaks and it says leaks detected. Perfect. So this is in your hands. So that's why although you recommend .gitignore file, you can recommend the common patterns, you can recommend the pre-commit hook, but as a DevSecOps engineer, make sure you add this CI/CD as well to your repositories so that you are 100% sure that even if someone tries to break the rules, even if a developer is willingly or unknowingly trying to push a secret, it can be through pull request, it can be through commit, it is blocked by your CI/CD workflow. So now we are done with the first 5 concepts. So we learned about .gitignore, pre-commit hook, git leaks, we learned about repository scanning, and we also learned how to integrate git leaks into GitHub Actions. Now let's learn about branch protection rules. Very simple. So branch protection rules, you must have seen whenever you're working on the main branch. You must have seen the main branch sometimes throwing up a pop-up that your main branch is not protected. The reason is simple. So you can automatically push changes to the main branch, which should not be the case in the enterprise. For example, if you notice, I was running git push and I was pushing the changes directly to the main branch. For example, I created a lot of files here, the abc.py, text.txt, test.py, and I directly push them without any pull request, which is a bad practice. No developer, no DevOps engineer should be able to do that. On the main branch, a pull request should be created, and that pull request should always be reviewed by the fellow engineers. The review process is mandatory. Now to do that, you need to protect the main branch. How do you do that? Go to the settings, and in the settings, head to branches, and here just add a new branch rule set. It's very simple. Add the branch rule set, call it as branch protection, for example. Here you can enforce the branch protection status. So if you make it active, that means most of the branches will stick to the branch protection. All that you have to do, in the target branch, provide the name of the branch. So you can say the default branch, which becomes the main branch. Along with that, you can also include branches with the patterns. For example, all the release branches, all the feature branches. That way you can also add. Now what will you add in the branch protection? As I told you, the most important thing that you will do, require a pull request before merging. The description also explains here, require all commits to be made to a non-target branch and submitted via a pull request before they are merged to the main branch. Just check this box, scroll down and click on the create. That's it. Branch protection is now enabled to the main branch. Even if I try to push to the main branch now, it will not be pushed. Now let's take a look at RBAC. What is RBAC? Role-based access control. Fortunately, when you are dealing with public Git repositories, for example, you are on GitHub or you are on Bitbucket, RBAC is very simple. So if you are a DevOps engineer, you can grant yourself admin access. For developers, you can grant write access. For QA engineers, you can grant read access, so on. How will you do that? Just head to collaborators section. If you are doing it for your entire organization, within the organization settings, you will find option to do that. But because we are working on a repo, you need to invite the collaborator. Let's say I invite Veeramalla, which is my GitHub user ID, for example. Okay. Of course, I cannot invite myself, but if I invite myself, during the time of invitation, I can grant the read access, write access, or admin access. So this way, whenever someone joins your organization, you can invite them and you can grant them with the required permission. That's all. It's very simple when you are dealing with public Git repositories on platforms like GitHub or Bitbucket. Now let's look at the most important thing, which I told you, mandatory reviews. So what if you want 2 mandatory reviews? Every time a pull request is created, right now, for example, this is a pull request that Funny has created. Now I can directly go to the pull request and I can merge the pull request, right? Maybe the CI checks will run on the PR, but I can merge it without a peer reviewing the pull request. That is, without a fellow colleague reviewing the pull request. What if you want to enforce 2 mandatory reviews? Only after 2 mandatory reviews and only after the CI checks are passing, the pull request has to be merged. You can do that by using the mandatory reviews option on this GitHub or Bitbucket. Again, very simple. Go to the settings. In the settings, go to the branches, the branch protection rules that we created, right? Similarly, if you scroll down, when you enable the automatic pull request, require a pull request before merging, here you can say number of reviews that are required. So if I say 2 reviews are required, the pull request will be merged only when 2 approvals are provided. And of course, I can also say require review from specific team, require review from specific person as well. How do you define the person? You provide the name of the person in the code owner's file. This is what I was talking about. I said we will learn about code owners. What is code owners? On open source repositories, you will have 300 to 400 contributors. Even within your organization, you might have a lot of contributors, but only certain people in your organization should merge the pull requests, right? There can be 20 developers, but only 5 senior developers. What you can do, you can check this option, require review from code owners, and you will create a code owners file. Simple. The name of the file is code owners, just like how we created .gitignore. Here we will create a code owners file, and within the code owners, we will provide the GitHub usernames of those persons. If you go to popular open source repositories, you will find the same practice. They will add the code owners and then they will check that option so that whenever a pull request is created, GitHub automatically requests the code owners to review the PRs. Now, finally, let's talk about Dependabot. Okay, so what is Dependabot? Now, this is a very, very important thing, especially when it comes to DevSecOps. This is introduced by Git distribution systems like GitHub. What Dependabot does, it is capable of looking into the packages that are used by your applications. For example, your application is a Golang based application. Dependabot can continuously look at your go.mod file and it can see what are the versions of the packages in your go.mod, and whenever there is a vulnerability in the version, let's say you are using XYZ package and the XYZ package version that you are using is 1.0. This morning, a vulnerability is introduced on this particular version. Now, obviously, you will be late because you cannot know all the vulnerabilities that are happening across the world. So you might take 2 to 3 days to fix this vulnerability. Someone has to look at it, someone has to report it. But what Dependabot is capable of, it's a bot, it's an application that will constantly monitor your repository. It will constantly look at your go.mod file, not only go.mod, it can be pom.xml or it can be the npm related packages, anything. Even it can be your Docker related packages. It will monitor all of them. It will look at vulnerability database, a database that has all the vulnerabilities in the world. And if there is a package that is vulnerable, it will automatically create a pull request and it can also merge the pull request. So within the minutes, a vulnerability is disclosed in the world, Dependabot automatically creates a pull request and updates the version in your repository so that you are safe from the vulnerability. Let me show you an example. Popular open source projects do it. So this is Argo CD operator project, which I used to contribute. If you look at .github, along with the CI files, you will find dependabot.yaml. Now this dependabot.yaml, because this is a Git repository, the DevOps engineer here added this particular lines. So look for go.mod, it's in the root repository, check every day and create a pull request. Pull request limit is 10 so that Dependabot will not spam the repository. Similarly, let's say you have npm, all that you have to do is change the file. That's it. Okay, Docker as well, Docker registry, and all the folders where you have the Docker related content. So Dependabot is very, very useful if you are working with multiple applications. You cannot look for vulnerabilities in different applications. Developers cannot do it, but Dependabot can do it because it is a bot. One more time, what it will do? It will basically look at your YAML file, pom.xml or go.mod, npm related file, and it will compare the version with vulnerability database. If your version is vulnerable, automatically it creates a pull request and updates your go.mod file. It can also merge the file for you so that by the time you realize Dependabot already fixed the issue for you. So these are 10 common patterns that DevSecOps engineers follow within the organization. .gitignore, pre-commit hooks, Git leaks, repository scanning, integrating Git leaks into CI/CD, branch protection rules, RBAC, mandatory reviews, code owners, and Dependabot. If you have any questions, do let me know in the comment section and make sure you go through the README file for the quick revision. See you all in the next video. Take care.